Flip Geometry Lesson 3-2, we are going to be talking about angles and parallel lines. When you finish this one, you'll be able to use the theorems to determine the relationships between specific pairs of angles. We talked about those in 3-1, and now we're going to look at the relationships between them when you have parallel lines. You will also be able to use algebra to find angle measurements. Okay, so in 3-1, we talked about corresponding angles. But now, if we have two parallel lines that are cut by a transversal, remember, I'm going to highlight the transversal here. We've got two parallel lines that are cut by a transversal, then each pair of corresponding angles is congruent. So if I'm looking at this figure here, we've got our transversal, we've got our two parallel lines, then I can say that angle 1 is going to be congruent to angle 3. I could also say that angle 2 is congruent to angle 4. Angle 5 is congruent to angle 7. And angle 6 is congruent to angle 8. Each of these pairs of corresponding angles is going to be congruent to each other. I think I ran out of colors. Well, here's an orange one. There you go. In this figure, the measure of angle 11 is 51 degrees. We need to find the measure of angle 15. Let's first take a look at and find the relationship between angle 11 and angle 15. We can see that they are corresponding angles, and because they are across parallel lines, we know now that those two are congruent angles. So if we know one of them is 51 degrees, measure of angle 11, then angle 15 is also going to be 51 degrees. In this next problem, we know that measure of angle 11 is 51 degrees again. We need to find the measure of angle 16 this time. So, we're looking at measure of angle 11 and 16. Now, we just said a second ago that 11 and 15, I'm going to highlight those in a different color. 11 and 15 were congruent to each other because they are corresponding angles across parallel lines. But now let's take a look at the relationship between 15 and 16. These two are vertical angles. So as we learned in chapter 1, they are also congruent to each other. So 11, 15, and 16 are all congruent to each other. So that means if the measure of angle 11 is 51 degrees, and that's congruent to this angle, which is also 51 degrees, that means the measure of angle 16 also equals 51 degrees. Now let's take a look at the alternate interior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. From our previous lesson, we know that angles 2 and 6 are alternate interior angles in this figure, so we can say that angles 2 and 6 are congruent to each other. We can also say that 3 and 7 are congruent to each other. There goes 2 and 6, and 3 and 7 are going to be congruent to one another. Now, consecutive interior angles theorem says that if two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. So let's take a look at angles 2 and angle 3. Those two are going to be consecutive interior angles, and since they are cut by a transversal along the parallel lines, they're going to be supplementary. So what does that mean? Again, our definition of supplementary means that those two angles are going to add up to equal 180 degrees. The same thing goes for 7 and 6. Angles 6 and angle 7 will add up. The measures, they will add up to equal 180 degrees. So we got 6 and 7. And we've got angles 2 and 3. The last one we're going to look at is the alternate exterior angles theorem, which says if two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. So again, from our previous lesson, angles 1 and 5 are alternate exterior angles, so they're going to be congruent to each other. Also, 8 and 4 are also going to be congruent to each other. So 1 and 5 and 4 and 8. The diagram represents the floor tiles in Joe's house. So we know that all of these lines, because they're going to be tiles, they're going to be right next to each other, and they're going to all be parallel to each other. So I'm going to go ahead and mark those lines, those horizontal lines parallel, and these slanted lines, they're going to be parallel to each other. That's why I used different number of markings. So we want to know if the measure of angle 2 is 125 degrees. We need to find out what the measure of angle 3 is. Let's look at these. Angle 2 and angle 3. We know that these are going to be alternate interior angles, and since they are across parallel lines on the interior of parallel lines cut by a transversal, then those two are going to be congruent to each other. So if the measure of angle 2 is 125, then the measure of angle 3 is also 125 degrees. We could do the same thing here for this problem that we did for the last one. We need to find angle 4. But first, again, I'm going to mark my lines parallel just so I know that they are. Okay, and the measure of angle 2 is 125. And we need to find the measure of angle 4. Now, we don't know a relationship between these two that we know of. We haven't looked at anything like that. But we do know the measure of angle 2 and angle 3 are going to be alternate interior angles like we did in the last problem. So angle 2 and angle 3 are going to be congruent to each other. Okay, so this 125, I'm going to go ahead and write 125 here so you can see it. 125 degrees. Okay, now 3 and 4, what's the relationship between those two? That, as we can see, is a linear pair. 125 is going to be supplementary to this angle 4. So if this is, like I said, if this is 125, then angle 4, you subtract from 180, the measure of angle 4 will be 55 degrees. The last problem we're going to take a look at uses this figure that we have here to the right. And it says if measure of angle 5 is equal to 2x minus 10 and the measure of angle 7 is x plus 15, we need to find x. So let's take a look at angle 5 and angle 7. Now, they are on the same side of this transversal. I'm going to call this one the transversal, if I can just highlight this thing. And they are on the same side, and they're going to be in the same position. So those are going to be corresponding angles. And as we know, corresponding angles across parallel lines are going to be congruent. So I can automatically say that the measure of angle 5 is congruent to the measure of angle 7. And we know measure of angle 5 is 2x minus 10. Angle 7 is x plus 15. And now all we have to do is solve for x. So I'm going to start by subtracting x from both sides. I'm left here with x minus 10 equals 15. Add 10 to both sides. And x equals 25. Again, remember that we're only solving for x, and we found x. If I would have asked you to tell me what the measure for angle 5 would be, I would plug that back in to 2x minus 10, 2 times 25 minus 10, which is 50 minus 10, and that would have been 40 degrees. But I didn't ask for that. I just asked you for the value of x. I just wanted to show you that just in case I'd asked you for the measure of angle 5, this is what you would have done. You would have plugged this back into that equation there. Ladies and gentlemen, boys and girls, that is the end of lesson 3-2, angles and parallel lines. Again, I would advise this was a semi-short lesson. Go ahead and view it again if you can, just to make sure that you didn't miss anything, make sure that you got everything down right. If not, ask me any questions when you see me, and I will see you in class.